Light travels in straight lines. Shining a powerful light source through a thin slit produces a straight, narrow beam. Place a glass block in its path and the beam starts to behave differently as the block is rotated. Some of the light is reflected, the rest passes into the glass. The light bends in one direction as it enters the block, and in the other as it emerges from the lower edge. This shift in direction is called refraction. To work out what's happening, think of light as a series of waves. This ripple tank uses a dipper to send parallel water waves across its surface. Putting a plastic sheet into the water makes this part of the tank shallower than the rest. Waves travel more slowly in shallow water. This change in speed changes the wavelength. The wavelength on the top is shorter than the one on the bottom. When the sheet is at an angle, the waves also change direction. The wave fronts bend as they reach the plastic sheet. To understand how speed can cause a change of direction, imagine a truck approaching marshy ground. If the marsh is at an angle, the right wheel slows first. The left carries on at speed for longer, swinging the truck round. So when light hits a glass block, it changes direction because it changes speed. Place a glass trough in the beam, and you can see how water also affects the path of light. The bending of light helps explain why this apparently straight stick is in fact bent. While this bent stick is actually straight. Refraction tricks our eyes, making us think that the stick is nearer the surface than it actually is. These gannets have to take this into account when they're diving for their underwater prey. Pass a ray of light through a semicircular glass block, and again it's both reflected and refracted. This happens at the straight edge. As the block is rotated, the angle at which the refracted ray leaves the block changes. Eventually, there's no refracted light. Instead, all the incident light is reflected back inside the block. This is known as total internal reflection. At a certain angle, the light stays inside this plastic rod. Total internal reflection allows light to travel through a curved shape. A laser beam can even be made to travel along a curved stream of water. Optical fibres work by the total internal reflection of light. As well as being decorative, they also have practical uses. Telecommunications rely on total internal reflection to transport information along cables underground.